Hello, friends, and welcome back to the Snoozy Scientist, where we gently explore the mysteries of our world, one sleepy yawn at a time. Tonight, we're going to drift slowly into one of the most haunting truths about our past. You see, for most of history, we were not alone. Humanity was not a single face, but a crowded family of many. Across continents and ages, different kinds of humans once shared the earth. They walked the same lands, lit the same fires, raised children, and gazed up at the same stars. At some point, there were at least 9 different species of humans alive at the same time. Some were tall and strong, with heavy brows and wide chests built for cold. Others were small and nimble, barely the size of a child, yet clever enough to shape tools and hunt. Some lived in icy tundras, others in tropical forests or on isolated islands. Together, they were a family of humankind, but one by one, they vanished, their bones left scattered in caves and riverbeds across the planet. Today, only we remain, Homo sapiens. This truth opens mysteries that have haunted scientists for decades. Why are we the only survivors? Did we destroy them in battles over food and territory? Did we outcompete them with sharper tools and stronger cooperation? Or did we simply absorb them, their lineages fading as we intermingled until only echoes were left? And perhaps the most haunting question of all, could more lost species still be waiting, undiscovered, in the depths of the earth? Tonight, we'll drift back through time, meeting every human species we lost. We'll uncover what they looked like, how they lived, and why they vanished. We'll explore what their absence means for us, the last survivors. And perhaps, in piecing together their stories, we will find a reflection of ourselves. If you're already enjoying this quiet journey together, it would mean so much if you gave this video a gentle like or subscribe to the channel for more sleepy science stories. And if you'd like to share, I'd love to know, where in the world are you winding down from tonight, and what time is it there? It's always a joy to see how far across the globe this little corner of science drifts. So now, take a slow breath, let your shoulders soften, and let's begin. The story of our species begins not in solitude, but in a crowded family tree that once spanned the world. To understand this, we must step back into the age known as the Pleistocene. It stretched across more than 2.5 million years, a span so vast that it can be hard to grasp. Entire landscapes rose and fell in that time. Climates shifted like tides, and animals both magnificent and strange walked the earth. This was an age of ice and fire, of shifting continents and restless skies, and at its heart, it was the age when many kinds of humans shared the planet together. The Pleistocene was a restless time. Vast ice sheets grew like glittering white shields across the northern hemisphere, pressing southward until they carved valleys and ground mountains into stone dust. Then, over thousands of years, the glaciers melted, flooding the land with rivers and seas. The climate swung back and forth, sometimes bitterly cold, sometimes unexpectedly warm. In these shifting environments, different species of humans took root, each adapting to their corner of the earth in their own way. Around them lived giants. Mammoths marched across frozen tundras, woolly rhinoceroses grazed the icy plains, and saber-toothed cats waited in the shadows. There were ground sloths the size of small houses, towering elk with antlers that stretched wider than a car, and flocks of great flightless birds that could outrun a galloping horse. To survive among such creatures, humans needed cunning, cooperation, and the ability to shape tools from the world around them. Yet the humans of this age were not a single people. When we say the word human today, we instinctively think only of ourselves, Homo sapiens. But during the Pleistocene, The term human meant something far broader. There were many forms of us, each with bodies, faces, and minds shaped by the demands of their environments. Some had heavy brows and wide chests, built to endure the cold winds of the Ice Age. Others were small and slender, perfectly suited for survival on tropical islands. Each was a different experiment in what it meant to be human. The family tree of our kind did not rise like a single trunk stretching straight upward. Instead, it branched and forked, sometimes flourishing, sometimes ending abruptly. Among the earliest known members were Homo habilis, the so-called handyman, who learned to shape stones into sharp edges. Then came Homo erectus, one of the greatest wanderers the world has ever known, who spread from Africa across Asia and survived for nearly 2 million years. From them emerged Homo heidelbergensis, hunters with powerful builds, who may have been the first to construct simple shelters. In Europe, they gave rise to the Neanderthals, our closest kin, while in Africa, their line would eventually lead to us. In the shadowed depths of caves in South Africa lived Homo naledi, with small brains, yet a puzzling spark of complexity. In the forests of the Philippines, another branch emerged, Homo luzonensis, with a unique blend of ancient and modern traits. On the island of Flores, a tiny cousin, no taller than a child, once hunted and lit fires. They are remembered now as the hobbits, Homo floresiensis. Far to the north, in Siberia, there were the Denisovans, known less from bones than from the whispers of their DNA that still echo in our own. And recently, in China, the discovery of a massive skull has pointed to yet another mystery, Homo longi, the so-called dragon man, whose true place in our lineage is still being debated. For millions of years, these many humans lived and thrived, sometimes side by side, sometimes separated by oceans and mountains, each adjusting to the demands of their world. It is only in hindsight that we can see the richness of this family. Imagine walking through a landscape of the past and seeing not just one kind of human, but several, some tall and strong, others small and wiry, some with faces we would almost recognize in a crowd, and others with features so different that they might seem uncanny, yet they all belong to the same wider story. Today we look around and see only one face left, our own. Homo sapiens is the sole survivor of this once crowded family tree. Every other branch has broken away and fallen into silence, leaving behind only fragments of bone, the occasional artifact, and the faint genetic traces woven into our blood. To know this is to feel both wonder and loneliness. We are the children of a family that no longer gathers, the last branch of a tree that once reached across the earth. When we think of the humans who came before us, none stand as hauntingly close as the Neanderthals. They were not distant figures, strange and alien on the edges of our family tree. They were our shadow twins, walking alongside us for hundreds of thousands of years. Their story is not one of primitive cavemen as they were once imagined, but of a people who lived, loved, and struggled, much as we did. The Neanderthals first appeared nearly 400,000 years ago, their range stretching across the cold plains of Europe and into Western Asia. They emerged into a world shaped by ice. Vast glaciers pressed down from the north, grinding the land and chilling the air. To survive, their bodies became sturdy, built to endure the bitter winds and freezing winters. Their frames were wide and powerful, with thick chests and muscular arms. Their faces carried heavy brows and broad noses that helped warm the icy air before it reached their lungs. Everything about them spoke of adaptation to the cold, yet their strength was matched by their intelligence. On average, their brains were slightly larger than those of modern humans. These were not dull creatures stumbling through the dark. They were skilled hunters who coordinated in groups, bringing down mammoths, bison, and reindeer. They mastered fire, not only for warmth but for cooking, for light, and perhaps for gatherings that brought their communities together. In the glow of those fires, families likely shared food, stories, and rituals, much like we do around our tables today. The Neanderthals were also makers. They chipped stone into blades and scrapers, weapons and tools of remarkable precision. They crafted ornaments from shells, teeth, and colored pigments. Bits of ochre and beads have been found in sites once occupied by them, hinting at a sense of beauty or perhaps of identity. In some caves, hand stencils marked in red still cling to the walls, among the earliest known symbolic expressions on Earth. These marks whisper across time that Neanderthals, too, had minds that could imagine, create, and leave behind meaning. Perhaps most moving is the evidence of how they treated their dead. Graves discovered across Europe suggest that they did not simply abandon the fallen. Bodies were laid carefully in the earth, sometimes accompanied by tools or ornaments. Such gestures imply reverence, or grief, or perhaps a hope that something lay beyond the stillness of death. To picture a Neanderthal kneeling beside the body of a companion, arranging the grave with care, is to glimpse a tenderness that feels achingly familiar. And yet, despite all of this closeness, they are gone. Around 40,000 years ago, the last Neanderthals disappeared from the record. Why they vanished remains one of the great mysteries of prehistory. Some scientists suggest that our own ancestors, arriving in Europe and Asia, outcompeted them for food and territory. Others believe that climate shifts pushed their already small populations past the point of recovery. Still others point to disease or the fragile mathematics of survival when numbers dwindle too low. The truth may lie in a combination of all of these pressures. What makes their absence even more poignant is how intertwined we were. Modern genetic studies reveal that Neanderthals did not vanish entirely. They live on in fragments of DNA carried within us. If you trace your ancestry outside of Africa, you likely carry 1 to 2% of Neanderthal genes. These bits of inheritance shape small details of our bodies and even parts of our immune system. They are echoes of long forgotten meetings, moments when two humans of different kinds came together and created life. To think of them as gone is only partly true. They no longer walk the earth, no longer light fires or carve stones, yet their presence lingers in us. In every breath, in every glance, there are whispers of our shadow twins, so close to us that we can still feel them within our blood. The story of the Neanderthals is not just about extinction, it is about kinship, about how narrow the line is between survival and silence. They were almost us, yet they were not. We carry them forward, unknowingly, as part of who we are, and their absence opens a question that has followed us ever since. Why did we remain when they did not? There is one human species whose presence was uncovered not through the discovery of complete skeletons or ancient villages, but through whispers written into our very cells. They are the Denisovans, a people more present in our blood than in the ground. Their story is not built from caves filled with tools or elaborate burials, but from tiny fragments that tell us they were once real, once alive, once walking across the same landscapes as our ancestors. The first trace of them came in 2008 from a cave in the Altai Mountains of Siberia. Scientists found a single bone fragment, so small it was almost overlooked, part of a finger belonging to a young girl who lived more than 50,000 years ago. At first, it seemed unremarkable, just another shard among countless others. But when geneticists studied it, what they saw was astonishing. The DNA locked inside did not match Neanderthals, nor did it match modern humans. It was something different, a hidden branch of the human family tree. With that fragment, A whole new species had been uncovered, one that had never been seen before. Unlike the Neanderthals, Denisovans have left us very little in the way of fossils. A few teeth, a jawbone from Tibet, a fragment of a skull, but no complete skeletons. We cannot yet reconstruct their faces with certainty, nor can we walk through their settlements. Their existence lingers as a faint outline, an impression more genetic than physical, and yet in some ways they are closer to us than many other extinct humans, because they left their mark inside our bodies. Modern DNA analysis shows that Denisovans interbred with our ancestors, leaving behind genetic gifts that still shape us today. People living in parts of Melanesia and Papua New Guinea carry as much as 5% Denisovan DNA, while smaller traces appear in many populations across Asia. In Tibet, their genetic legacy is even clearer. High in the Himalayas, where oxygen thins and the air grows harsh, the ability of people to survive is due in part to Denisovan genes. One specific genetic variant they passed on helps modern Tibetans use oxygen more efficiently, an invisible inheritance that allows life to flourish in a place where lungs should struggle. Their contributions were not limited to the heights of the mountains. Denisovan genes also strengthen parts of our immune systems, helping humans adapt to new diseases and environments as they spread across the continents. In this way, they are still with us, their survival strategies woven into our own. We carry them forward every time our bodies fight off an illness or take a breath in thin air. And yet, what makes them haunting is how little else we know. We cannot picture their art if they made any. We do not know the full shape of their culture, what songs they might have sung, or what stories they told under starlight. Their bones are scarce, their traces faint, and yet their presence is undeniable. They were real, and they are part of us. Imagine this for a moment. A young Denisovan child running through the Siberian forest, her laughter echoing between the trees, a family gathering around a fire, perhaps sharing a meal of roasted meat. Their voices would have been human voices, their hands human hands. They were close enough to us that love, conflict, and union were possible, close enough that their lives mingled with ours and created descendants who still walk the earth. Yet now they are gone, remembered not in their own right, but through the genes we carry like ghostly fingerprints. It is a peculiar kind of existence, to be more alive in genomes than in bones. Their story unfolds in laboratories rather than caves, where scientists peer through microscopes and sequencing machines to pull their whispers out of ancient fragments. Each discovery is a revelation, a reminder that the human story is far more tangled and shared than we once imagined. The Denisovans show us that the family we lost still lingers in ways we are only beginning to understand. On a remote island in Indonesia, far from the great ice sheets and open plains where many of our relatives lived, there once thrived a very different kind of human. Their bones were first uncovered in the early years of this century inside a limestone cave on the island of Flores. What the scientists found stunned the world. The skeleton belonged to a being unmistakably human, yet far smaller than any living person. Standing just a little over 1 meter tall, this species seemed almost like a child in stature, but the proportions and features revealed it was an adult. These were the island hobbits, a lost branch of humankind, now known as Homo floresiensis. The discovery challenged everything we thought we knew about the human story. At first, some wondered if the bones represented a diseased individual, a member of our own species with some form of growth disorder. But as more remains were studied, it became clear that this was no accident of illness. It was a separate species adapted perfectly to the island world it inhabited. The hobbits of Flores had walked the earth tens of thousands of years ago, sharing time with Neanderthals, Denisovans, and even our own early ancestors. Life on an island has a way of shaping creatures into forms that seem almost magical. On Flores, elephants shrank until they became tiny stegodons, barely larger than a cow. Birds grew larger, reptiles became giants, and in this same crucible of isolation, humans became small. Scientists call this phenomenon island dwarfism, a process where limited resources favor smaller bodies that require less food and energy. For Homo floresiensis, being small was a survival strategy, a way to live in balance with a world where every scrap of meat and every root mattered. Despite their size, these little humans were capable and clever. Their brains were smaller than ours, about the size of a grapefruit, yet this did not limit their ingenuity. In the cave where their remains were found, stone tools were scattered across the layers of earth, shaped with skill for cutting and scraping. Evidence suggests they hunted the miniature elephants that shared their island, working together to bring down animals far larger than themselves. They likely foraged in the dense forests, gathered fruits and roots, and used fire to cook and survive the nights. It is almost impossible not to imagine the scene: small human figures moving through the jungle, their shadows flickering in the light of a fire, voices rising softly in the night as families gathered, children no taller than a modern toddler, but with minds sharp enough to craft blades from stone. They were humans, just like us, yet so different that their world feels like a dream, and they lived until surprisingly recently. The youngest bones of Homo floresiensis date to around 50,000 years ago, which means they walked the earth at the same time as our own species. Somewhere across the seas, early Homo sapiens were spreading through Asia and Australia, while on Flores, these little humans continued their way of life, unaware of the vast changes unfolding beyond their shores. For tens of thousands of years, they had carved out their existence, and then, suddenly, they were gone. The reasons for their disappearance remain uncertain. Perhaps volcanic eruptions on the island reshaped their habitat. Perhaps the arrival of modern humans pushed them to extinction through competition or even direct conflict. Or perhaps, like so many other small populations, their numbers dwindled until survival became impossible. Whatever the cause, the hobbits vanished, leaving behind only their bones and their tools, silent testaments to a world that no longer exists. What lingers is the strangeness of their story. They remind us that being human was never a single thing. It was not about size, or brain volume, or strength alone. The hobbits of Flores were tiny, but they were survivors, tool makers, hunters, and caretakers of their island world. Their existence shatters the idea that there was one straight path to humanity. Instead, it shows us that human life has always been a mosaic of possibilities, each shaped by the land, the climate, and the choices of those who came before us. Their story is a quiet reminder that the human family once included beings who would seem almost mythical to us today. Little people who thrived on a faraway island, living lives that were entirely their own until their voices faded into silence. In the dark recesses of South Africa's Rising Star cave system, more than 30 meters below the surface, lies a story that reshaped how we think about what it means to be human. It began in 2013 when cavers wriggling through a passage so narrow it was named the Chute stumbled upon bones scattered across the chamber floor. At first, no one could have imagined what those fragments belonged to, but as the remains were carefully retrieved, piece by piece, the picture began to emerge. This was a new species of human, unlike any that had been seen before. It was given the name Homo naledi, meaning star in the local Sotho language, in honor of the cave where it was found. What made the discovery so astonishing was not just the number of bones, though more than 15 individuals were eventually recovered, making it one of the richest hominin sites ever found. It was the nature of the species itself. Homo naledi's body was a strange blend of old and new, primitive and modern, as though evolution had stitched together a mosaic. Their hands were long and curved, perfect for climbing, yet their feet were shaped for walking upright like us. Their skulls were small, holding brains no larger than an orange, yet the way they appeared in the cave suggested behaviors once thought to belong only to bigger brained humans. The bones of Homo naledi were not scattered by predators or floods. They seemed to have been placed deliberately, carried deep into the cave, and left there in the darkness. This suggested something startling. These small brained humans may have been burying their dead. If true, it would mean that ritual, care for the deceased, and perhaps even symbolic thought were not the exclusive domain of Homo sapiens or Neanderthals. It would mean that the spark of culture flickered in a brain far smaller than ours, a reminder that intelligence does not live only in size, but in the mysteries of structure and connection. The chambers of the rising star cave became a kind of time capsule. As excavators worked under headlamps in the pitch black, they uncovered more secrets, bones belonging to the very young and the very old, evidence that entire groups were brought there. Tools were absent, fire was not present, and yet the presence of the bodies themselves raised questions that continue to stir debate. Was this deliberate burial or a form of disposal of the dead? Was it ritual or something simpler? Whatever the answer, the act of repeatedly placing bodies in that hidden chamber points to choices, to intention, to something recognizably human. The most haunting revelation came when the bones were dated. At first, many assumed Homo naledi must be ancient, perhaps more than 1 million years old, a relic species lingering in a cave. But the test revealed something unexpected. These individuals had lived between 230,000 and 300,000 years ago. That was not long ago in evolutionary time. It meant that Homo naledi was alive at the same moment as early Homo sapiens in Africa, and long after Neanderthals had already spread into Europe. The timeline placed them in a world where multiple species of humans were still coexisting, and perhaps even encountering one another. To imagine it is unsettling. Somewhere in southern Africa, while our own ancestors painted their earliest stories in ochre and stone, another kind of human lived in parallel, small in brain, but possibly capable of acts we once thought belonged only to us. They would have looked different, their foreheads sloping, their frames more slender, their faces primitive, and yet their minds may have carried thoughts that touched on meaning, loss, and memory. Homo naledi unsettles the neat categories we once drew. They ask us to reconsider what defines humanity. Is it the size of the brain, or is it the choices we make, the symbols we leave behind, the care we show for one another even in death? The bones resting in the quiet dark of Rising Star Cave whisper that intelligence and compassion may have deeper, more varied roots than we ever imagined. More than 2 million years ago, long before Neanderthals carved ornaments or Homo erectus mastered fire, there was a smaller, less imposing human whose name means handyman. This was Homo habilis, remembered as the first true maker of tools. Their world was raw and dangerous, filled with predators and shifting landscapes, yet from their hands came the first sparks of a technology that would one day change the destiny of humankind. Homo habilis was not tall. Many stood little more than 1.5 meters in height. Their arms were long, their bodies lightly built, and their skulls still bore the shape of an earlier age, with sloping foreheads and jaws that jutted forward. Their brains were larger than those of their more ape-like ancestors, yet smaller than those of later humans. By appearance, they were a bridge, balanced between what had come before and what was still to come. What set them apart was not their size or their strength, but their hands. In sites scattered across East Africa, from Olduvai Gorge in Tanzania to Kubifora in Kenya, archaeologists have uncovered the tools they left behind: sharp flakes chipped from stone, heavy cores shaped into choppers, scrapers used to clean hides or slice through bone. These were the first known tools intentionally created by humans, not stumbled upon by chance, but made with purpose. The Oldowan industry, as scientists call it, was simple by later standards, yet it marked the dawn of technology. Imagine the scene along a riverbank more than 2 million years ago. A group of Homo habilis gathers, their eyes scanning the ground for the right kind of rock. One strikes stone against stone, and a sharp-edged flake breaks free. It gleams in the sun, and soon it is used to cut into the flesh of an animal recently brought down by predators. With this tool, they can scrape away meat, crack open bones for marrow, and make use of resources that bare hands and teeth could never access. The tools are crude, but their impact is immense. For the first time, humans are shaping the world around them with intention, bending stone to serve their needs. This leap opened doors that biology alone could not. With tools, Homo habilis could scavenge more effectively, extracting nourishment from carcasses abandoned by lions or hyenas. They could process plants, break tough shells, and defend themselves with sharpened edges. Every flake carried the promise of survival. More importantly, every tool carried the memory of an idea passed from one hand to another, from one generation to the next. Technology was born not in the flash of brilliance of a single mind, but in the quiet repetition of countless hands striking stone. Their lives were still precarious. Fossil evidence shows that Homo habilis faced constant danger. They lived among saber-toothed cats, giant crocodiles, and massive predators that dwarfed them. Their bones often bear the marks of scavengers, reminders of how vulnerable they were. Yet even in this harsh world, they endured. They gathered in small groups, likely bound by cooperation and care, and their tools gave them an edge that made survival just a little more possible. Though their technology was simple, the mental shift it represented was profound. To see in a stone not just a rock, but the possibility of a blade required imagination. To strike with precision until the right edge was revealed required planning. These were small steps, but they were steps into a future that no other animal had taken. The tools of Homo habilis may look unremarkable to modern eyes, but in their time, they were revolutionary. It is humbling to think that the devices filling our world today, from spacecraft to microscopes, can trace their lineage back to those first chipped stones. The smartphones in our pockets, the lights above our heads, even the pen or keyboard with which we write, all descend in spirit from the flakes of sharp rock made by Homo habilis. Their legacy is not measured in monuments or art, but in the quiet persistence of an idea that humans could change their world with their own hands. Homo habilis lived for hundreds of thousands of years before giving way to other species, their place in the story of humanity secure as the first inventors. They remind us that progress does not always come in leaps, but in small, sharp edges struck from the stubborn face of stone. Long before our species began its journey across the earth, another kind of human had already set out on the road. This was Homo erectus, the upright human, a figure who would become the first great wanderer in our long and tangled family story. They emerged in Africa nearly 2 million years ago, and then, astonishingly, they spread far beyond it, walking into lands no human had ever seen before. Their footprints have been found in Asia, in the Middle East, and across islands that must have seemed like entire new worlds. To picture them is to imagine endurance. Their bodies were strong and built for distance. Unlike some of the smaller or more fragile species of human, Homo erectus had long legs and shorter arms, well suited for walking and running across open ground. They could travel far, following the shifting herds of animals, and they had the stamina to adapt to whatever terrain lay ahead. They carried with them not only their bodies, but the skills that would allow them to survive in strange new places. For almost 2 million years, Homo erectus endured. That length of time is almost impossible to grasp. Our own species, Homo sapiens, has existed for barely 300,000 years, a fraction of the span that Erectus walked the earth. In their longevity, they were unmatched. They survived ice ages and droughts, shifting coastlines and erupting volcanoes, predators and prey, and through it all, they kept moving. To endure for so long is not just a matter of strength, but of adaptability, of finding ways to live when the world changes around you. One of their most profound achievements was fire. While earlier humans may have stumbled upon flames kindled by lightning or lava, Homo erectus appears to have been the first to truly master it. In ancient hearths discovered in caves and open-air sites, there are signs of repeated burning, charcoal, and scorched bones that speak of controlled flames. Fire gave them more than warmth. It provided protection from animals, the ability to cook food, and the comfort of light in the dark. Cooked food was easier to chew and digest, unlocking more energy from every bite, which in turn may have fueled the growth of their bodies and brains. Around firelight, bonds of community would have strengthened, stories may have been shared, and the night was pushed back just enough to create a circle of safety. Homo erectus were also makers of tools, carrying with them hand axes chipped from stone. These teardrop-shaped tools, symmetrical and sharp, became the hallmark of their ingenuity. Simple enough to produce, yet versatile in use, they allowed erectus to cut meat, scrape hides, and carve wood. They are among the most enduring artifacts in all of prehistory, appearing across continents for over 1 million years with little change in form. These tools, like the species who made them, were symbols of persistence. Their spread across the world is one of the most remarkable migrations in the history of life. Fossils of Homo erectus have been found as far east as Indonesia, on the island of Java, where they lived until about 100,000 years ago. To reach such places, they would have had to cross bodies of water, whether by accident or by design. This suggests a curiosity and resilience that carried them beyond the limits of familiar ground into territories where no other human had yet set foot. Despite their success, Homo erectus did not leave behind the same artistic expressions that later species did. No carvings or cave paintings are tied to them, yet their achievements were not diminished by this absence. Their legacy is survival itself, the longest-lived human species we know, spanning nearly 20 times the length of our recorded history. Their story is one of patience and perseverance, a reminder that endurance can be as powerful as brilliance. Homo erectus were the pioneers who first showed that humans could be a global species. They proved it was possible to leave the cradle of Africa and thrive in distant lands, from the plains of Eurasia to the islands of Southeast Asia. In their journeys, they opened the paths that later species, including our own, would walk. Among the many branches of our family tree, one stands as a great crossroads, a species whose descendants would go on to become both our closest cousins and ourselves. This was Homo heidelbergensis, a powerful and resourceful human who lived between 600,000 and 200,000 years ago. They were not as ancient as Homo erectus, yet they carried forward the achievements of their wandering forebears and added something new. In their lives, we can glimpse the beginnings of what would later unfold into Neanderthals in Europe and Homo sapiens in Africa. Heidelbergensis was physically striking. Their bodies were tall and strong, often more robust than ours. Some individuals reached heights of nearly 2 meters, with broad shoulders and muscular frames built for endurance in the hunt. Their skulls carried large brow ridges and wide faces, but inside those skulls were brains nearly as large as our own, sometimes even larger. They were fully capable of complex thought, planning, and cooperation. To look into their eyes, had we been able, would have been to meet a gaze not unlike our own. What set Homo heidelbergensis apart was their growing ability to shape not only tools, but the spaces in which they lived. Archaeological sites reveal traces of the first known shelters built by human hands at places like Terra Amata in France. Post holes mark where wooden structures once stood, protecting families from wind and rain. These early huts were simple, made of branches and covered with hides, but they represented something profound. For the first time, humans were not only adapting to the environment, they were beginning to reshape it to suit themselves. Their skill as hunters was formidable. Evidence from sites across Europe and Africa shows that Homo heidelbergensis organized group hunts for large animals. Spears of carefully worked wood have been found preserved in the mud of ancient lakes, some more than 400,000 years old. These spears were finely balanced, aerodynamic weapons designed for thrusting or throwing. Around them lay the remains of horses, deer, and even elephants, suggesting that heidelbergensis could plan, coordinate, and bring down prey much larger than themselves. The hunts would have required teamwork, communication, and courage, binding communities together in shared struggle and triumph. But perhaps the most extraordinary aspect of Homo heidelbergensis is their place in the human family. Genetic and fossil evidence suggests that they were the common ancestor of two of the most important lineages. In Europe, populations of heidelbergensis gradually adapted to the cold climates, developing shorter, stockier bodies and traits that would become characteristic of Neanderthals. In Africa, other groups evolved differently, with lighter builds and traits that would give rise to the first Homo sapiens. From this one species, two very different futures emerged, leading to both our cousins and ourselves. To think of them is to imagine a world on the edge of great change. Around their fires, in their shelters, with their spears leaning nearby, Homo heidelbergensis could never have known that their descendants would one day cover the earth. They were simply living, surviving, passing knowledge from one generation to the next. Yet from their endurance, the seeds of our own existence were sown. Fossils of heidelbergensis have been found from Spain to South Africa, from the valleys of Germany to the savannas of Kenya. Each discovery adds another fragment to their story. A jawbone in Heidelberg, Germany, gave them their name. A skull in Zambia revealed their massive brains and heavy brows. Wooden tools in northern Europe spoke of their hunts. Together, these fragments create the image of a species that was both ancient and familiar, bridging the gap between the deep past and the dawn of our own kind. The legacy of Homo heidelbergensis is not only in the bones they left behind, but in the paths they opened. They remind us that we are not the product of a straight line of progress, but of many branches, many experiments in survival. From them came diversity, and from that diversity came us. In 2019, the scientific world was startled by a discovery on the island of Luzon in the Philippines. Hidden deep inside Callao Cave, researchers uncovered bones and teeth that did not match any known human species. They were small, worn by time, yet in their details lay a puzzle that would change how we see the human story. This was a new branch of our family, now called Homo luzonensis. The remains were fragmentary, a few finger and toe bones, parts of a femur, and several teeth. But even in these scattered pieces, there was something extraordinary. The teeth were unusually small, even more delicate than those of Homo floresiensis, the hobbits of Indonesia. The finger and toe bones curved in a way that recalled ancient species millions of years older, almost as if this little known human carried echoes of a much deeper past. It was as if time had folded back on itself, creating a mosaic of traits that did not quite fit into the neat categories scientists had built. Homo luzonensis was clearly human, yet it was not us, nor Neanderthal, nor Denisovan, nor hobbit. It was something else, something unexpected. The mix of features left researchers both amazed and puzzled. Some traits were modern, resembling our own kind, while others looked primitive, belonging to humans who had lived long before. This strange blend suggested that the path of human evolution was far less straight than we once imagined. It was not a simple march from primitive to advanced, but a web of branching and intertwining lineages, each adapting in their own way to survive. The dating of the bones added to the mystery. They were at least 50,000 years old, which meant that Homo luzonensis lived at the same time as early Homo sapiens, Neanderthals, Denisovans, and the hobbits of Flores. Once again, the world was not a stage for one kind of human, but a gathering place for many. On the scattered islands of Southeast Asia, far from the icy plains of Europe or the savannas of Africa, small-bodied humans had carved out their own existence, hidden from the rest of the world. To live on Luzon meant living on an island isolated by deep waters. These people could not have walked there. They must have crossed seas in some way, whether drifting on natural rafts or perhaps building simple vessels. This hints at a surprising ability, for even small populations with limited resources were capable of journeys that carried them across oceans. It reminds us that the spirit of exploration, the push to see what lies beyond the horizon, has always been part of being human. What their lives looked like remains largely a mystery. The bones are too few to reconstruct their faces with certainty, and no tools or ornaments have yet been tied directly to them. Still, the cave floor where they were found suggests they were comfortable in these limestone shelters, returning again and again across generations. Perhaps they hunted the deer and pigs of the forests, foraged fruits in the jungle, and fished along the island's shores. Their small bodies may have been well suited for climbing trees and navigating dense tropical terrain. Homo luzonensis is a reminder of how little we truly know. Even in the 21st century, with satellites scanning every corner of the Earth and genomes being sequenced in gleaming laboratories, entirely new human species are still being found. Each discovery humbles us. It shows that the story of humanity is not yet complete. Beneath the soil of caves, in forgotten valleys, and under layers of forest and stone, the bones of other cousins may still be waiting. The Philippine puzzle remains unsolved. Who were these people? How long did they live on Luzon? Did they ever meet others, or were they forever isolated on their island home? And most haunting of all, how many more lost humans lie undiscovered, their traces hidden in caves we have not yet entered? In 2018, a skull wrapped in mystery was pulled from decades of hiding. It had been kept in secret since the 1930s, concealed during a time of war and unrest, and only recently did it come into the hands of scientists. When they examined it, they realized they were looking at one of the most remarkable human fossils ever found. The skull was massive, with a great brow ridge, deep eye sockets, and a brain case large enough to rival our own. It came from northeastern China, near the city of Harbin, and was given the name Homo longi, or Dragon Man, after the river that flows through the region. What makes Dragon Man so extraordinary is not just its size, but the puzzle it poses. The skull is both familiar and strange, combining traits that link it to other humans, yet standing apart in ways that resist easy classification. Some researchers suggest it may be a Denisovan, the ghostly cousins known mostly from DNA and fragments of bone. Others argue it represents a distinct species, a branch of humanity not yet fully recognized until this moment. Whatever the truth, Homo longi has added another twist to the tangled story of our family tree. The skull itself speaks of power. Its face is broad, with large square eye sockets and cheekbones that flare outward. The brow is heavy, casting shadows across what would once have been deep-set eyes. Yet the brain case is high and rounded, close in shape to that of modern humans. It suggests a creature intelligent and capable, one that could have looked into the distance with thoughts not so unlike our own. Unlike Neanderthals, whose skulls slope low and long, Dragon Man's head had a more vertical profile, hinting at a different evolutionary path. Dating of the skull places it at least 146,000 years old. That makes it a contemporary of both Homo sapiens and Neanderthals, living in a time when multiple human species shared the earth. To imagine this is to picture a world where not just one kind of human walked the riversides and grasslands of Asia, but perhaps several, each with their own strengths and adaptations. Dragon Man was large-bodied, perhaps robust enough to withstand cold winters and harsh climates, thriving in the landscapes of northern China during the Ice Age. The possibility that Homo longi is a Denisovan adds another layer of intrigue. Denisovans are one of the most mysterious branches of humanity, known mostly from genetic traces and a few scattered fossils. A finger bone in Siberia, a jawbone in Tibet, a tooth here and there. If Dragon Man is truly one of them, then at last we may have a face to place upon the shadowy name. His features would reveal what those long-lost cousins looked like, bridging the gap between the DNA in our blood and the bones beneath the ground. But if Homo longi is not a Denisovan, then it represents something even more remarkable, a completely new kind of human, one that lived alongside us and yet has remained hidden until now. The human story would then gain yet another branch, another reminder of how crowded and diverse our past truly was. It would mean that even as we uncover more fossils, we are still only scratching the surface of how many kinds of us there once were. The discovery of Dragon Man forces us to reimagine the human map of Asia. For too long, our understanding was shaped by finds in Europe and Africa. Now, the lands of China and beyond are yielding their secrets, reminding us that humanity's history was never confined to one place. The great rivers, mountains, and plains of Asia may still hold the bones of other unknown cousins, waiting for the day when science will reveal them. Homo longi is both presence and question. The skull rests heavy and solid, proof of a human who lived and breathed. Yet in its mixture of traits, in its uncertain place on the family tree, it stands as a mystery. Was Dragon Man a Denisovan, a lost brother whose genes linger in us today? Or was he something altogether separate, another cousin erased by time? The only certainty is that our story is not finished. Every fossil brings us closer, yet every new find opens doors we did not know existed. The face of Dragon Man stares back at us from the past, asking not just who he was, but how many others we have yet to discover. When we look back at the long story of humanity, it is tempting to picture a straight path, a single line, beginning with primitive ancestors and leading step by step toward us. But the truth is not so simple. The human tree was never a single trunk rising upward. It was a tangle of branches, spreading, splitting, and sometimes breaking off into silence. For long stretches of time, many kinds of humans lived side by side, each shaped by the landscapes they called home. Geography played a powerful hand in this diversity. Mountains, rivers, oceans, and deserts acted not only as barriers but as cradles. Populations of early humans became separated, cut off from one another, sometimes for tens of thousands of years. In that isolation, each group evolved in its own direction, adapting to the specific demands of its environment. A valley in Africa, an island in Southeast Asia, a frozen tundra in Europe, each setting was like a laboratory, shaping bodies, minds, and survival strategies. On islands, small humans like Homo floresiensis and Homo luzonensis developed, their bodies reduced in size to conserve energy where food was scarce. In colder climates, stocky Neanderthals grew broad chests and powerful muscles to withstand the chill of Ice Age winters. In the high mountains of Asia, Denisovans evolved genetic traits that would one day help modern Tibetans survive at great altitudes. Across the globe, the same family adapted in countless ways, branching into forms so distinct that at first glance they might not even have recognized one another as kin. The variety of these species was not just physical, it extended into the ways they made tools, gathered food, and interacted with the world. Some species specialized in hunting great animals, crafting spears, and working together to bring down massive prey. Others survived by scavenging, cracking open bones for the rich marrow inside. Still others lived by foraging fruits, roots, and shellfish, using tools shaped from stone or bone to expand the range of what could be eaten. Each species found its niche, carving out a way of life that allowed them to endure for thousands upon thousands of years. This overlapping of species tells us something profound. Humanity was not inevitable. There was not a single chosen path, but many experiments in being human, all unfolding at once. For nearly all of prehistory, Homo sapiens was not alone. We were simply one branch among many, sharing the earth with cousins whose abilities and intelligence were closer to ours than to any other creature alive. The image of them all existing together is haunting. Imagine a world 50,000 years ago. In Europe, Neanderthals were setting fires in caves, decorating themselves with ornaments, and caring for their dead. In Siberia, Denisovans roamed the forests and left genetic traces in the people who live there today. Far to the south, on the islands of Indonesia and the Philippines, tiny humans lived out their lives in tropical forests. In Africa, our own ancestors were beginning to craft symbols, to paint and carve and tell stories. The planet held many versions of humanity at once, each one shaped by a different corner of the world. What is striking is how long this coexistence lasted. For millions of years, there was no single dominant human. Species rose, flourished, and sometimes faded away, while others continued. Their timelines overlapped, stretching like braided threads rather than a single rope. Only recently, in evolutionary terms, did all those threads but one unravel, leaving us as the lone survivors. To understand why so many species existed together, it helps to think of humanity not as a race toward progress, but as a great branching experiment. Every new species was an attempt, shaped by chance, by geography, by climate, and by need. Some adaptations worked for a time, allowing survival in harsh or unusual conditions. Others, though clever or strong, proved fragile when the environment shifted or when competition grew too fierce. Diversity was the rule, not the exception. The sheer number of species tells us how complex our story truly is. At least 9 are known to have lived within the last few 100,000 years, but there may have been more, still hidden in caves or sediments yet to be uncovered. Each discovery adds another branch, another reminder that our lineage is not a neat ladder, but a forest of possibilities. The mystery of why only one branch remains is one that continues to echo through science, but the fact that so many once existed together shows us that humanity is not a singular definition, but a spectrum. Being human has always meant many things, expressed in many forms, across time and across the globe. Across the long arc of human history, one force has stood quietly but powerfully in the background, shaping destinies, creating new possibilities, and bringing others to an end. That force is climate. The rise and fall of temperatures, the advance and retreat of ice, the sudden arrival of droughts or floods. These shifts carved the landscapes we walked upon and determined who would survive, who would vanish, and who would adapt. Climate was not only a stage upon which humans lived, it was the great shaper, sculpting the very paths of our existence. During the Pleistocene epoch, the world was in constant motion between extremes. Ice ages swept across the continents, glaciers advancing like vast white armies that ground mountains into dust and locked oceans into frozen masses. Between these glacial periods came warmer interludes, when the ice retreated and rivers swelled across fertile plains. These rhythms unfolded not over years, but over tens of thousands of years, and with each cycle, human species were pushed to move, to change, or to fade away. For the Neanderthals of Europe, climate was both ally and enemy. Their stocky bodies and wide chests were suited for the cold, but when sudden warming arrived, the ecosystems that supported them shifted. Forests spread where tundra had once been, changing the animals they relied upon. For Homo erectus, the long wanderers, expanding deserts and shifting savannas in Africa and Asia demanded migrations. They followed herds into new regions, learning to endure in environments that were at once harsh and full of opportunity. Sudden changes were often the most devastating. A volcanic eruption could plunge skies into darkness, cooling the air and killing vegetation. A drought could dry rivers that had sustained life for generations. For small populations of humans, such events could mean the difference between survival and extinction. When resources thinned, groups were forced to move, sometimes crossing dangerous new frontiers in search of water or food. These movements scattered human species across continents, creating isolation that allowed them to evolve apart, yet also exposing them to risks that could wipe them away. In Africa, where our own ancestors emerged, climate shifts played a decisive role. The land alternated between green, fertile periods and long stretches of aridity. Lakes swelled and then dried, forests gave way to grasslands and then returned again. These cycles forced Homo sapiens to adapt in ways that may have encouraged flexibility and innovation. When resources were scarce, they turned to new tools, new foods, new strategies for survival. Climate, in this way, acted as a silent teacher, rewarding those who could adjust and punishing those who could not. It is striking to consider that while we think of ourselves as builders of culture and makers of technology, so much of our history was dictated by forces we could not control. Climate created deserts that cut off one group from another, leading to the rise of new species in isolation. Climate created land bridges during ice ages, opening paths across continents that would later vanish under rising seas. It was climate that sculpted the opportunities and barriers that shaped where humans could go and what they could become. The record of bones and stones carries the fingerprints of these changes. Populations appear in one layer of sediment and vanish in the next, sometimes replaced by another species better suited to the new conditions. The fossils of Homo heidelbergensis in Europe tell of a people thriving in one climate, only to disappear as Neanderthals emerged in the colder periods that followed. In Asia, the story of Denisovans is written against a backdrop of fluctuating forests and high plateaus, where adaptations to thin air became essential for survival. Climate was not cruel by intention, it was indifferent, shifting with the pull of the Earth's orbit, with the tilt of its axis, with eruptions and atmospheric currents. Yet its indifference was powerful enough to sculpt the fate of our kin. It created the spaces where they thrived, and it closed them just as swiftly. In this way, it was both creator and destroyer, offering life with one hand and silence with the other. To understand the human story is to understand that we are children of climate. Every breath, every journey, every invention was forged in response to its restless rhythms. The human family that once sprawled across the earth was a forest of possibilities, pruned and nurtured by the invisible hand of shifting skies. Some branches flourished, others snapped and fell, and the tree that remains is shaped by the storms of time, long before cities, before writing, before even the earliest hints of art carved into bone or stone. There was fire. To us today, fire may feel ordinary, something we turn on with the flick of a switch or the spark of a lighter. Yet for our ancestors, fire was not just light in the darkness. It was a boundary between fear and safety, between hunger and nourishment, between the fragile limits of the body and the vast potential of the mind. The mastery of fire is one of the greatest milestones in human history. It offered warmth in freezing nights when the winds of the ice ages swept across the land. It turned caves and open camps into places of safety, where wild animals kept their distance from the flickering glow. And most of all, it transformed food. With fire, raw roots softened, meat became tender, and dangerous toxins in plants were reduced. The energy locked away in food became more accessible, and that simple shift would ripple into our very biology. Cooking was not just about taste or convenience. It changed the way our bodies grew. Chewing raw roots, seeds, and meat demanded enormous jaws and powerful teeth, along with long hours of grinding and tearing. But when food could be softened by heat, the burden eased. Over generations, human jaws grew smaller and teeth less imposing. The calories once lost to tough chewing were redirected, and some scientists believe this energy helped fuel another transformation, the expansion of the brain. The human brain is a hungry organ. Though it makes up only a small fraction of our body weight, it consumes more energy than any other organ. In earlier species, before fire, feeding such a large brain would have been nearly impossible. Cooking food released more calories with less effort, giving our ancestors a steady supply of fuel for their growing minds. This shift may have opened the door to more complex thought, to memory, planning, and imagination. Yet fire was not mastered equally by all human species. Evidence suggests that Homo erectus may have been among the first to control flames nearly 1.5 million years ago, building simple hearths where groups could gather. The warm glow of those fires may have lit not only the darkness of the night, but also the spark of human society. As people sat together, shared food, and exchanged the beginnings of stories. For Neanderthals, fire was a companion in harsh northern climates. Hearths discovered in their caves show repeated use, with layers of ash building up over generations. They likely carried embers with them, nurturing the coals of one fire until it became the start of another. For them, as for us, fire was survival, but other species may not have relied on it so strongly. Some of the smaller humans, like Homo floresiensis, appear to have used it more sparingly, perhaps limited by their environment or by knowledge that never spread as widely. The uneven use of fire may have shaped destinies. Those who relied on it gained protection against predators, longer waking hours after sunset, and diets that allowed them to thrive even in harsh places. Those who lacked it may have been more vulnerable, bound tightly to the rhythms of daylight and to the foods they could eat raw. In this way, fire acted as a dividing line, separating not only day from night, but the future from the past. It is also likely that fire played a role in the shaping of human culture. Around its glow, eyes would meet, hands would gesture, and voices would rise in conversation. Stories may have begun here, carried on smoke and sparks into the night. Fire made possible the first true gatherings, moments where individuals became communities, and communities became something greater than the sum of their parts. The story of fire is not only about survival, it is about transformation of body and of mind. The flames that warmed the hands of our ancestors also burned inside their skulls, fueling thought and invention. In every flicker of light, there was a step forward, not just in the mastery of the world, but in the mastery of themselves. For tens of thousands of years, the world was not divided between us and them. It was instead a patchwork of humankinds, sometimes separated by distance, sometimes overlapping, and at times meeting face to face. When Homo sapiens stepped out of Africa and began their long journey across the continents, they were not entering an empty world. The lands ahead were already home to other humans who had thrived there for countless generations. And so, our paths crossed. Archaeology and genetics together have revealed that these encounters were not fleeting. They were intimate, sometimes violent, sometimes tender, and they left traces in our very bodies. One of the clearest examples comes from our meetings with the Neanderthals. They had been shaping Europe and Western Asia for hundreds of thousands of years, perfectly adapted to ice and cold. When our ancestors arrived, we did not simply replace them overnight. We lived alongside them, campfires glowing in valleys where both species gathered, tools clinking against stone in the same landscapes. And more than that, we intermingled. DNA pulled from ancient bones has shown that Neanderthals and Homo sapiens shared more than just territory. They shared lives. Interbreeding took place multiple times, in multiple places, over thousands of years. Today, every person of non-African descent carries fragments of Neanderthal DNA, a reminder that we are not pure branches of a single tree, but mosaics stitched together by ancient unions. These inherited fragments shaped us in quiet, practical ways. Some influenced our skin and hair, perhaps helping early humans adjust to colder, dimmer climates. Others affected our immune systems, fine-tuning our defenses against new diseases. And the Neanderthals were not the only ones. Farther east, another shadowy lineage was waiting, the Denisovans. Unlike the Neanderthals, who left behind skeletons and skulls, Denisovans remain mostly ghosts in our genomes, known from only a handful of bones and teeth. Yet their genetic footprint tells a story of repeated encounters. Among the people of Tibet, a Denisovan gene still allows survival in high altitudes where the air is thin and harsh. In Melanesia and parts of Southeast Asia, entire strands of Denisovan DNA continue to live on, quietly shaping resistance to certain illnesses. Though we cannot see their faces, they are still with us, encoded in blood and breath. These exchanges blur the idea of species as sharp dividing lines. The world of ancient humans was not a neatly ordered family tree, but a web of crossings and minglings. Each meeting carried consequences, not just for survival, but for identity. For sapiens, stepping into these shared spaces meant carrying away fragments of other lives, fragments that became our own. Imagine what it might have felt like to meet them, a Neanderthal standing before you, with eyes so human, yet features that seemed both familiar and alien. A Denisovan who might have sung, laughed, and grieved in ways much like ours, but whose language we may never recover. Some encounters might have ended in fear, with rival bands clashing over food and water. Others may have ended in companionship, in bonds that bridge difference. In every case, the encounters left echoes that time itself could not erase. Today, science lets us peer into those echoes. When we examine our DNA, we find their fingerprints woven through us, like threads in a tapestry. Each fragment carries whispers of ancient nights when two kinds of humans came together and became one. In this way, none of them are entirely gone. They live in the curve of a jawline, in the resilience of lungs high in the mountains, in the way our immune systems fight against invisible enemies. We are not simply Homo sapiens standing apart, but mosaics of the lost, carrying in our veins the shadows of Neanderthals and Denisovans. Their story is not just one of disappearance, but of union, survival, and memory etched into the living fabric of who we are. The story of humans meeting one another is not only written in DNA, it is also written in broken bones. Archaeologists studying ancient remains sometimes find marks that speak of more than accidents or hunts. Skulls bearing fractures, ribs pierced in ways that echo the shapes of stone blades, and skeletons showing patterns of trauma that hint at struggle. These are the shadows of conflict, preserved in the silence of the earth. For Homo sapiens moving into new lands, every valley and forest was already claimed. Neanderthals had walked the caves of Europe long before our arrival. Denisovans had claimed stretches of Asia. Homo floresiensis and Homo luzonensis had carved out lives on islands far to the south. Each species had its own knowledge of the land, its own way of surviving, and its own hold over food and shelter. When our ancestors entered, they were not stepping into an empty stage. They were stepping into occupied worlds. Competition is a quiet force, but relentless. Animals compete over water, over prey, over safe ground. Humans, with their intelligence sharpened by survival, were no different. Imagine two groups encountering one another at the edge of a river. One has fished and hunted there for generations. The other has just arrived, weary from long travel, needing the same fish, the same game, the same fresh water. Tension would have risen quickly. Sometimes sharing might have been possible, but often the cost of scarcity left little room for generosity. Weapons, at first simple stone and wood, would have become more than tools for hunting. Spears, sharpened with care, could be raised in defense or attack. Archaeologists have found Neanderthal bones with wounds that match the shapes of early spear points, leading some to wonder whether encounters with sapiens turned violent. Not all trauma is evidence of battle, but the pattern across sites suggests that clashes may have happened more than once. Territory is life. To control the best caves, the richest hunting grounds, the safest migration routes, was to increase a group's chances of survival. If one band had stronger numbers, more advanced strategies, or the will to fight, they could displace another. Sapiens, with their larger social networks and flexible planning, may have had an edge. A group that could communicate more efficiently, rally more allies, or anticipate the movements of rivals would have been difficult to resist. But violence does not always need to be imagined as great battles. Often, it might have been sudden, desperate, and small. Two hunters crossing paths, a raid for food during a lean winter, the ambush of a smaller group by one that was larger. Small conflicts ripple outward, driving populations away, scattering families, and gradually shifting the balance of who remained. Over time, repeated losses could erode the strength of smaller species, pushing them closer to the edge. There is also a haunting possibility. Even when encounters were not overtly violent, the mere presence of sapiens could have been enough to weaken others. Competing for the same game animals, the same firewood, the same shelters, could make survival harder. The stress of competition leaves marks not only on bodies, but on entire populations. Groups forced into poorer lands, harsher climates, or less fertile hunting grounds would have seen their numbers dwindle. The struggle may not always have been seen in single battles, but in long, slow pressures that tipped survival in favor of one and against another. Archaeological hints also show that sapiens may have been more willing to travel long distances, expanding rapidly into new lands. This mobility itself could have created pressure, crowding out other humans who were more rooted in particular regions. The spread of sapiens might not have felt like a single invasion, but a steady tide, advancing wave after wave, until the other kinds of humans were left with less and less space. The bones tell fragments of this story. A cracked skull here, a pierced rib there, a site abandoned abruptly, as though those who once lived there were pushed out. These fragments suggest that conflict, whether open or quiet, may have been part of the reason why only one branch of humanity survived. Not the only reason, but one that left marks still visible thousands of years later. And so, along with genes shared through intimacy, there are scars left through struggle. Humanity's past was not only a story of connection and blending, but also of rivalry and survival. These shadows remind us that to endure, our ancestors sometimes had to fight, not only against the cold and the hunger, but against others who were as human as themselves. Some of the deadliest battles in human history may have been fought not with weapons, but with things too small to see. When different species of humans met, they did not only exchange tools, stories, or genes. They also carried with them invisible passengers, the microscopic organisms that lived in their blood, their lungs, and their skin. Every community of humans, no matter how ancient, had its own set of microbes. These were viruses, bacteria, and parasites that their bodies had learned to live with over many generations. To them, these illnesses may have been minor irritations, the kind of fevers or coughs that most could recover from. But when carried into a group that had never encountered them before, those same microbes could turn devastating. We know this story well from much later times. When Europeans crossed into the Americas only a few centuries ago, they brought with them diseases like smallpox and measles. These were illnesses Europeans had endured for centuries, but indigenous peoples had no defenses against them. The result was catastrophic. Entire villages collapsed, sometimes within weeks, and populations fell by more than half in just a few generations. The tragedy reshaped entire continents. If this could happen in recorded history, it is not difficult to imagine it happening tens of thousands of years ago. When Homo sapiens expanded into Europe and Asia, they would have carried with them new pathogens. A single cold-like virus, a stomach parasite, or a bacterial infection could have spread quickly through a Neanderthal band or a Denisovan family group. With their numbers already small, even a modest outbreak could cut deeply. Unlike sapiens, who often lived in larger and more connected groups, many of the other humans existed in scattered, isolated populations. Some estimates suggest that there may have been only a few thousand Neanderthals alive at any one time across all of Europe. Homo floresiensis and Homo luzonensis were even more vulnerable, living on islands with very limited gene pools. For groups this small, disease did not need to be highly lethal to leave lasting damage. If even a handful of skilled hunters or mothers with children were lost, the ripple effects could last for generations. Imagine a Neanderthal camp deep in a cold valley. A hunter returns coughing after an encounter with sapiens. Within days, others begin to sicken. Fires burn low because no one has the strength to gather wood. Children cry in hunger because fewer hands can bring food. These small, unseen tragedies leave no fossils, no tools in the ground, no carvings in caves. Yet they may have been as decisive in shaping human survival as any weapon. What makes this possibility even more haunting is that the reverse might also have been true. Sapiens, too, could have been exposed to microbes from the species they met. But here, their larger and more connected groups may have given them an advantage. A disease might have swept through, but wider networks of people and faster recovery could help ensure that their lineage did not collapse. For smaller, more fragile populations, however, the margin between survival and extinction was thinner. Diseases also leave another kind of trace. The DNA of modern humans still carries signs of ancient immune battles. Certain genes that help us resist infections appear to have been inherited directly from Neanderthals and Denisovans. These genetic gifts suggest that encounters between species involved more than conflict or curiosity. They may have included moments where survival itself depended on borrowing resilience from others. The very fact that these genes remain in us shows how deeply disease shaped the fate of all humans. We may never know the exact illnesses that spread between species. Bones rarely hold clear evidence of infections like viruses. But the patterns of small populations fading away, combined with what we know from later human history, create a picture that is difficult to ignore. The disappearance of entire human species may have been hastened not only by climate shifts or competition, but by the silent advance of disease. This kind of extinction is quiet. No battlefields, no dramatic events. Just the slow dwindling of numbers, the fading of voices around a fire, the emptying of caves that once echoed with life. It is a reminder that survival is fragile and that what cannot be seen can sometimes be more powerful than what is. When we look back at the vanished branches of our family tree, one pattern emerges with quiet clarity. Many of the human species that shared the world with us lived in populations so small that their survival was always precarious. Where Homo sapiens eventually numbered in millions, scattered across continents, others lived and died in groups that may have only counted in the thousands. Such small numbers made them vulnerable not only to sudden catastrophes, but to the slow erosion of chance itself. Life in small groups can feel intimate. Picture a cluster of perhaps 30 or 40 individuals gathered around a fire in a cave, children learning from their elders, hunters returning from the plains, and families huddled together against the cold. Within this circle, there is familiarity and strength, but there is also fragility. If a single harsh winter strikes, or if a disease passes through, or if a handful of hunters fail to return, the group's survival begins to hang in delicate balance. Genetic studies suggest that some ancient humans had population sizes so small that in modern terms they might be considered endangered. Neanderthals, despite their wide distribution, appear to have lived in relatively isolated bands. Denisovans, though spread across Asia, may have been divided into small pockets, separated by mountains and rivers, rarely mixing with one another. For species limited to islands, like Homo floresiensis or Homo luzonensis, the numbers were even smaller, their world bounded by shorelines they could never cross. Such isolation created what scientists call genetic bottlenecks. In a large population, genes are shuffled widely, creating diversity that helps the group resist disease, adapt to new environments, and remain healthy. In a small population, Genes are recycled again and again within the same limited pool. Over time, harmful mutations can accumulate. Without enough fresh genetic material, the resilience of the group weakens. It becomes harder to resist infections, harder to adapt when climates shift, harder to survive the unexpected. The fossil record carries faint hints of this. Skeletal remains of Neanderthals sometimes show deformities linked to inbreeding. Certain bone structures repeat in ways that suggest limited diversity. This is not evidence of weakness in their daily lives. They were still strong, intelligent, and capable, but over many generations, the narrowing of possibilities made them less able to recover from losses. Small numbers also make groups vulnerable to chance. Imagine a volcanic eruption darkening the skies over an island where only a few hundred humans live. Even if many survive the event, the loss of key individuals, the best toolmaker, the most experienced hunter, the woman who holds the memory of migration routes, can ripple through the community in ways far beyond the simple count of lives lost. In a population of millions, knowledge is redundant and skills are widespread. In a population of hundreds, each person's role carries immense weight. Isolation can also mean vulnerability to shifts in the land itself. If a drought dries up a river, or if game animals migrate away, a small community may have no alternatives. They cannot afford to split further. They cannot send scouts too far without risking collapse. The very scale that makes them close-knit also makes them brittle. Homo sapiens, in contrast, formed wider networks. Archaeological evidence shows that our ancestors often exchanged tools, pigments, and even shell ornaments across distances of hundreds of kilometers. This web of connection acted like a safety net. If one group suffered hardship, they could turn to others for resources or mates, keeping their numbers and genetic diversity stronger. For the smaller species, cut off by geography or habit, no such safety net existed. When seen in this light, extinction does not always require violence or great catastrophes. Sometimes it only takes the quiet mathematics of small numbers. A few hard winters, a few lost families, a few too many closely related births. Over thousands of years, these small events can tip the balance. The disappearance of a species may not have been sudden but gradual, like the slow dimming of a fire when no one is left to tend it. The fragility of small populations is a reminder that survival is not only about strength or intelligence, it is also about scale, connection, and chance. For the many humans who once walked beside us, their world was held together by threads that were already thin. All it took was time and the weight of circumstance for those threads to fray and break. When archaeologists sift through caves and river valleys once inhabited by ancient humans, what they often uncover are not only bones and tools, but signs of something far more elusive. They find pigments ground from ochre, beads shaped from shells, carvings etched into stone, and flutes cut from bone. These traces are quiet whispers of culture, fragile evidence that Homo sapiens carried within them a deep need to share meaning. Culture, in its simplest sense, is the web of shared ideas that binds individuals together. It is not only about survival skills or tools, but about symbols, rituals, and the passing on of knowledge. In small groups struggling against ice and predators, these invisible threads of connection may have been the hidden weapon that gave our species an advantage. Consider a group of early sapiens gathered in the flickering glow of a fire. One person tells a story, perhaps about the spirits of animals or the lessons of an ancestor. Others listen, children wide-eyed, adults nodding slowly. This moment is more than entertainment. It is a way of reinforcing memory, values, and unity. The story travels beyond the lifespan of the teller, carried by those who listen and repeat it in turn. This is culture at work, a survival tool disguised as narrative. Neanderthals, too, showed signs of symbolic thought. They buried their dead and may have painted cave walls. Yet among sapiens, these behaviors appear more widespread, more varied, and more deeply woven into daily life. Cave paintings in Europe depict herds of animals with astonishing detail, some layered in pigments thousands of years apart, suggesting tradition and continuity. Beads and ornaments appear across regions, often in similar forms, implying that groups were exchanging not only goods, but symbols of shared identity. Language may have been the foundation that allowed this symbolic world to flourish. Though we cannot hear the voices of our ancestors, their ability to coordinate hunts, teach toolmaking, and pass down knowledge hints at a capacity for structured communication. With language, ideas could leap from one mind to another, not bound by the limitations of gesture or demonstration. A single spark of innovation, such as a new way to shape a blade, could spread quickly across a band, and from there to distant groups. Rituals added another layer. Archaeological sites suggest that sapiens gathered in larger numbers than other human species, perhaps during seasonal migrations or shared hunts. In these gatherings, rituals could affirm alliances and strengthen bonds between distant groups. A dance performed around a fire or a chant repeated at dawn becomes more than an act. It becomes a marker of belonging, a way of saying, "We are one people." This collective identity may have allowed sapiens to cooperate on a scale that smaller, more isolated groups could not match. Where a Neanderthal band might consist of a few dozen individuals, sapiens could link many such groups through shared symbols and stories, creating networks that stretched across landscapes. These networks offered resilience. If one group faltered, another could provide support. If resources ran thin, knowledge of distant lands or techniques could be passed along. Art and symbols also had a subtler effect. They encouraged imagination. To paint an animal on a cave wall or to carve a figure from ivory is to see beyond the immediate moment, to create something abstract. This mental flexibility may have extended to problem solving and planning. A mind that can invent myths can also imagine strategies for survival, for organizing hunts, for adapting to sudden changes in climate. In this way, culture became both shield and compass. It shielded groups by giving them unity, reducing the chances of collapse in times of stress. It served as a compass by pointing toward futures that had not yet come, guiding decisions with the weight of collective memory and imagination. Even today, fragments of that legacy are with us. Our rituals may look different, our stories more complex, but the same impulse connects us to those early gatherings in firelit caves. The survival of sapiens was not only about sharper tools or stronger bodies, it was about this invisible fabric of shared meaning woven across generations. Culture, with its songs, symbols, and stories, became a kind of inheritance that multiplied itself, shaping the destiny of a species that would one day stand alone. On the southern edge of Europe, where the land narrows into a rugged promontory facing the endless sweep of the Atlantic and the Mediterranean, the final chapter of the Neanderthals unfolded. Gibraltar, with its limestone caves and coastal cliffs, became one of their last sanctuaries. Here, long after their cousins elsewhere had vanished, a small community of Neanderthals clung to existence, living out the final centuries of a lineage that had once stretched across half the world. Archaeologists studying these caves have uncovered signs of their resilience. In Gorham's cave, darkened by the passage of tens of thousands of years, fragments of charred wood and blackened hearthstones speak of their last fires. The flames would have offered light against the cavern walls, warmth against the sea winds, and a center for gathering. Around those fires, the final Neanderthals cooked their food, knapped their flint tools, and told the stories that bound them together. The evidence suggests that these holdouts survived until about 37,000 years ago, possibly even more recently. By then, Homo sapiens had spread widely across Europe, their numbers growing, their networks stretching far beyond what the smaller Neanderthal groups could sustain. Yet in Gibraltar, sheltered by cliffs and nourished by the sea, the Neanderthals endured just a little longer. Their world would have been harsh but rich in its own way. The coastline provided shellfish, seabirds, and dolphins, while inland valleys still offered deer and wild boar. Archaeologists have found cut marks on bones that prove the Neanderthals here were skilled hunters and gatherers, able to draw sustenance from both land and sea. Flint tools, carefully shaped into scrapers and blades, tell of practiced hands and minds that adapted to their environment with ingenuity. But there is something deeply moving about the evidence from Gibraltar. Among the hearths and stone tools, scientists discovered markings etched into the rock floor of one cave. These cross-hatched lines do not appear to be random. Many believe they represent a deliberate act of carving, perhaps symbolic in nature. If true, they may be the last known expression of Neanderthal thought, scratched into stone as their kind faded from the earth. The image of those final fires is haunting. Imagine a group of perhaps only a few dozen individuals gathered together as night fell over the sea. Their children played in the flickering light. Their hunters planned the next day's efforts, and their elders carried the memory of countless generations. Outside the cave, the tides shifted, stars wheeled above, and the world slowly changed around them. With every year that passed, their numbers dwindled, not because they lacked strength or skill, but because the world no longer offered them the space they once had. The last Neanderthals were not ignorant of their condition, though we can never know how they understood it. They must have encountered Homo sapiens, perhaps even traded or interbred with them, as had happened in earlier times. Yet the balance was tipped. Where sapiens multiplied and spread, Neanderthal communities thinned, their fires growing fewer, their voices fading until silence took hold. Archaeologists sometimes describe Gibraltar as a refuge for the Neanderthals, a final safe harbor before the tide of history swept them away. The caves there preserve not only ash and stone but a sense of poignancy, as though time itself paused to record the end of a lineage that had thrived for hundreds of thousands of years. The emotional weight of this chapter in our shared history is immense. These were our shadow twins, so much like us in their strength, their creativity, and their bonds, yet they did not continue into the present. Their last fires in Gibraltar are more than archaeological remains. They are the echoes of a human story cut short, flames that burned brightly for a moment longer before going out forever. On the Indonesian island of Flores, the bones of tiny humans were found resting in limestone caves. Homo floresiensis, often called the hobbits, once thrived here, living lives that were both familiar and strange. They walked upright, crafted stone tools, and hunted small animals, yet they stood only a little over 1 meter tall, with heads much smaller than ours. For a time, these island people endured, separated from the wider world by vast seas, and then, without warning, they disappeared. Their extinction remains one of the most enduring mysteries in human history. The first question scientists ask is whether the island itself sealed their fate. Flores is part of the Pacific's volatile Ring of Fire, a chain of restless volcanoes that shape and reshape the land. Geological records show that the region was scarred by eruptions during the time when Floresiensis lived. A great eruption would have smothered forests, poisoned rivers, and buried fertile soil under ash. For an isolated population with no way to flee across the sea, such devastation could have been catastrophic. The loss of food and shelter might have been enough to end their story in only a few short generations. Another possibility lies in the arrival of new humans on the island. Fossils tell us that Homo sapiens reached nearby regions tens of thousands of years ago, their canoes carrying them across oceans to Australia and the surrounding islands. If sapiens set foot on Flores, the encounter with floresiensis would have been inevitable. What followed is uncertain. Did we outcompete them for resources, driving them into dwindling corners of the island until none were left? Or was there violence, a clash between two kinds of humans over hunting grounds, water sources, and shelter? Even if no open conflict took place, the presence of a larger, more numerous species could have tilted the balance, leaving the hobbits unable to endure. Climate, too, may have played its role. Around the time Floresiensis vanished, the Earth was gripped by shifting ice ages. Though the island of Flores sits in the tropics, changes in global climate could alter rainfall patterns, transforming lush forests into drier landscapes. Animals the hobbits depended on, such as the small elephants known as stegodons, may have dwindled. Rising seas could have reshaped the island itself, cutting off access to vital areas or compressing their range into smaller, more fragile habitats. For a population already limited in number, even slight changes in climate might have been enough to tip them toward extinction. There is also the quiet possibility that no single dramatic event ended them. Instead, their disappearance may have been the result of a slow unraveling, a chain of small pressures that accumulated over time. A volcanic eruption might have reduced their numbers. A period of drought could have weakened them further. The arrival of sapiens might have delivered the final blow. Extinction is often not a single moment, but the slow dimming of a flame, until one day no fires are lit, no footprints remain, and silence spreads over the land. What makes their disappearance so haunting is that it remains unresolved. Unlike Neanderthals, whose decline is recorded in DNA, or Denisovans, who live on in fragments of our genes, the hobbits leave no such legacy inside us. We carry only their mystery, a puzzle of bones and stones found in caves. Their extinction invites questions that cannot yet be answered. Did they watch the seas rise and the forests thin? Did they encounter sapiens and recognize, in us, a shadow of themselves? Did they vanish suddenly, or did the last of them live out quiet lives, unaware that they were the final ones? The hobbits remind us that even the smallest branch of our family tree carries weight and meaning. Their disappearance may have been caused by fire from the earth, competition from our kind, or the slow hand of climate. The truth, perhaps, is all of these woven together. But in their absence, they leave behind not only bones but wonder, a lingering question carved into the silence of their caves. Why did they vanish, and why are we still here? Among the many lost humans, perhaps none feel more like ghosts than the Denisovans. Unlike Neanderthals, whose bones lie in caves across Europe, or Floresiensis, whose skeletons rest in island soils, the Denisovans have left us almost nothing. A finger bone, a few teeth, fragments of skull. That is all that has been found in the ground, and yet, despite the scarcity of their fossils, their presence echoes powerfully within us. The Denisovans were first discovered not by sight, but by code. In 2010, scientists sequenced DNA from a fragment of finger bone found deep in the Denisova cave of Siberia. What emerged was astonishing. The genetic material did not match Neanderthals or Homo sapiens. It belonged to a separate branch of humanity, one we had never known existed. From a sliver of bone no longer than a coin, an entire hidden people emerged into the light. But the paradox of the Denisovans is that while their fossil record is vanishingly thin, their genetic legacy is immense. DNA studies reveal that Denisovans interbred with Homo sapiens, leaving traces that survive in modern populations. People in parts of Asia, Oceania, and especially among indigenous groups in Melanesia carry between 3 and 6% Denisovan DNA. Tibetans inherited from them a gene that helps the body adapt to high altitudes, allowing survival in thin mountain air. This means that even if their bones are scarce, the Denisovans still shape the lives of millions today. The question that lingers is where they lived and how far they ranged. If we judge by their DNA, Denisovans must have been widespread across Asia. Their genetic imprint appears in peoples thousands of kilometers apart, suggesting that they once inhabited vast regions from Siberia to Southeast Asia. Yet when we search the ground, we find almost nothing. Where are their campsites, their tools, their hearths? Why do we hold so much of their inheritance, but so little of their remains? Some scientists suggest that Denisovans may have thrived in regions where conditions are poor for preserving fossils. Warm and wet environments dissolve bone quickly, leaving behind almost no record. Others believe that we may have already unearthed their remains but misclassified them as belonging to other species, since their features might overlap with Neanderthals or archaic Homo sapiens. The fragments we do have suggest powerful jaws and teeth, larger than those of Neanderthals, hinting at robust bodies capable of enduring harsh environments, but the rest remains hidden. The Denisova cave in Siberia, where their name comes from, offers only faint glimpses. Layers of sediment hold traces of their DNA, showing that they lived there for tens of thousands of years, sometimes overlapping with Neanderthals. One fragment even belonged to a child whose mother was Neanderthal and father Denisovan, proof of their interwoven lives. Yet even in this cave, their physical presence is elusive. The cave is vast, filled with countless bones of animals and scattered tools, but the Denisovans themselves appear only in whispers, in fragments, in microscopic strands of DNA clinging to the soil. It is strange to imagine a species so influential, yet so hidden. They walked the same earth, gazed at the same skies, and mingled with our ancestors, yet their faces remain unknown. No artist can draw them with certainty, for no complete skull has ever been found. We know they were human, but not what they looked like. They remain a shadow, defined more by what lives on in us than by what lies in the ground. The mystery of the Denisovans lingers like an unfinished story. They must have been numerous, spread across continents, shaping the genetic fabric of future peoples. And yet, when we search the caves and riverbeds, their traces slip through our fingers. They remind us that history can hide in silence, that whole civilizations can leave behind legacies in blood rather than bone. Somewhere across the vast landscapes of Asia, their story waits, still buried, still unseen, in the dim light of caves and the quiet depths of ancient soil. Humans who are long gone still whisper to us, not through words or art or tools, but through fragments far smaller than the eye can see. DNA, that delicate spiral of life, holds the memory of their existence. Even when bones crumble and bodies turn to dust, the code sometimes lingers, locked in teeth, preserved in sediments, or hidden deep within the marrow of a fossil. With modern science, these traces have become keys to rediscovering species that once walked the earth beside us. It began with chance discoveries. A single finger bone found in Denisova cave, barely recognizable, changed everything when its DNA was sequenced. From that sliver emerged an entirely new species, the Denisovans, whose story was invisible to us until the code was read. What once seemed like silence suddenly became a chorus. That same technology has since been applied to countless fragments. A tooth dug from a cave floor in Siberia, a shard of jawbone in the mountains of Tibet, even sediments swept from the ground of caves where no bones remain. Each sample has the power to reveal the identity of a lost human. The process is painstaking. Ancient DNA is fragile, breaking into pieces over time, and easily overwhelmed by contamination from modern organisms. Scientists work in sealed laboratories, dressed in layers of protective clothing, brushing particles of bone with care so fine it borders on reverence. From these tiny fragments, they stitch together entire genomes, reconstructing the genetic identity of humans who died tens of thousands of years ago. With each new sequence, another branch of our family tree takes shape. What is remarkable is how much can be learned from so little. A single molar can carry the signature of a species. From the DNA inside, we learn what proteins built their bodies, what diseases they carried, and what traits they passed on. A few grains of soil from the floor of a cave can tell us not only which species lived there, but when they came and went, their genetic traces preserved like shadows in the earth. The ground itself becomes an archive, a library of ghosts. These genetic discoveries have reshaped the way we understand human history. Where once the story seemed simple, a straight line from Homo habilis to Homo sapiens, we now see a tangled web. Neanderthals, Denisovans, and sapiens all interbred, leaving traces of one another in their descendants. Small populations of mysterious humans, like Homo luzonensis, were revealed not through complete skeletons, but through fragments that DNA confirmed as distinct. Our family tree is no longer a clean diagram, but a network of crossings and overlaps, made visible only by the sequencing of ancient code. Every genome retrieved is like opening a time capsule. It allows scientists to compare species, to trace migrations, to watch the flow of genes across continents. From Denisovans, we know that high-altitude adaptations were passed to Tibetans, making survival possible in thin mountain air. From Neanderthals, we carry traits that shape our immune systems and even aspects of our skin and hair. Without sequencing, these connections would remain invisible. With it, the lost become present within us. The most haunting aspect of this work is that it reveals how incomplete our fossil record truly is. We may never find full skeletons of some species. Entire populations may have lived and died without leaving behind a single recognizable skull. Yet, through DNA, they rise again, their existence proven not by what we can see in stone, but by what pulses still in our blood. It is as though the earth itself has been storing their memory, waiting for us to learn how to read it. And so, with each fragment of bone or grain of soil, the human story is rewritten. Every discovery shifts the map of who we are and where we came from. The lost are not entirely gone. They remain hidden in the double helix, in the fragile code that once gave them life and still binds us together. When we think of humanity today, we see only one face. Across the globe, from deserts to mountains, from frozen tundra to tropical forests, there is just us, Homo sapiens. But for most of our history, the world of humans was not so singular. It was a mosaic, a chorus of different forms and strategies for survival, each shaped by its own landscapes and challenges. When the other human species vanished, it was not only their bodies that were lost, it was the richness of diversity itself, the many ways of being human that once coexisted. The Neanderthals were powerfully built, their wide chests and strong arms suited for the cold and heavy demands of Ice Age Europe. They were masters of persistence hunting, capable of bringing down massive prey such as mammoths or woolly rhinoceroses. Their lives were defined by strength and endurance, a physical answer to the frozen landscapes they called home. By contrast, the tiny Homo floresiensis, no taller than a small child, adapted to the forests of Flores Island. They survived not through force, but through agility, resourcefulness, and the ability to thrive in isolation, hunting birds and small animals with sharpened stone tools. Between these extremes were countless variations. Homo erectus, long-legged and resilient, became the first great wanderer, spreading across continents, enduring for nearly 2 million years. Homo naledi, with small brains yet surprising sophistication, may have performed rituals in the depths of caves, challenging our assumptions about intelligence and behavior. Denisovans left no full skeletons for us to study, yet their genes gave modern humans tools for survival at high altitudes and in new environments, suggesting they too had strategies finely tuned to their surroundings. Each lineage represented an experiment in endurance, a different response to the shifting climates and landscapes of the Pleistocene world. What we lost with their disappearance was not only physical diversity, but cultural richness as well. Neanderthals buried their dead and may have painted symbols on cave walls. They wore ornaments, perhaps to signal identity or belonging. The hobbits of Flores made tools and controlled fire, while the people of Luzon in the Philippines carried unique traits that spoke of yet another way of living. Even with the fragmentary evidence, we can see that culture did not belong to sapiens alone. Storytelling, ritual, creativity, and meaning seemed to emerge wherever humans lived, each group weaving its own thread into the wider fabric. Imagine a world where all these forms of humanity survived alongside us. Forests alive with the movements of small-bodied hobbits, mountains where Denisovans gazed across snowy ridges, valleys echoing with the voices of Neanderthals. Each species had ways of surviving that sapiens could have learned from. Instead of one dominant lineage, there might have been many, each contributing to a shared world. Their loss also narrowed the genetic diversity of humanity. In larger populations, variation allows for resilience against disease and change. With the extinction of other human groups, entire sets of genes vanished forever. A few fragments remain within us, passed down through interbreeding, but most were lost. The traits that once allowed humans to live in extreme cold, or adapt to small islands, or thrive with smaller brains, are gone. What remains is only the single path of Homo sapiens, a narrower branch of a once sprawling tree. This narrowing had consequences for culture as well. Different human species might have seen the world in ways we cannot imagine. They may have organized families differently, valued other skills, or created symbols we would not recognize. With their disappearance, those perspectives were silenced. We carry their echoes in artifacts, in pigments ground to dust, in bones etched with wear, but the living traditions, the songs and stories that might have passed down through their generations, are gone. The world we inherited is richer because of what they gave us through contact and shared genes, yet poorer because so much of their diversity disappeared. Their absence is a reminder that humanity was never destined to be one thing. It was once a spectrum, broad and varied, like colors across a sky. The loss of that spectrum leaves us with unanswered questions and perhaps a sense of loneliness. We are the only humans left, but once the world was filled with others who were just as real, just as alive, and just as human in their own ways. There was a time when the world held many faces of humanity. Valleys and forests echoed with different voices, and across mountains, rivers, and oceans, other kinds of humans walked, hunted, and dreamed. We were never alone. The earth was shared. It is almost impossible for us now, living in a world with only one surviving lineage, to imagine what it felt like when human diversity was the natural order of things. Today, when you look across a crowded city street or into the eyes of a stranger on a train, you see only Homo sapiens. No Neanderthal steps into view with a broad chest and a heavy brow. No Denisovan looks back with features unfamiliar, but still recognizably human. No small hobbit-like figure navigates the market with tools carved from stone. They are all gone. The streets, the forests, the mountains, and the caves belong to us alone. That solitude carries weight. We do not often think of ourselves as the last of something, yet in truth we are the last of an entire family. Imagine if the only remaining bird on Earth was a single species, or if the oceans held just one type of fish. The loss would feel unbearable, an emptying of life's richness. And yet, in the human story, this is precisely what happened. More than 99% of all human species are gone, leaving only us, the final survivors of a once crowded tree. This existential solitude is difficult to measure, yet it lingers in the background of our history. For most of our existence, the presence of others was a fact of life. Homo sapiens evolved in a world already inhabited by Neanderthals, Denisovans, and other cousins. Encounters with them shaped us, whether through conflict, cooperation, or the blending of bloodlines. Then, one by one, their fires went out. We remained, watching the silence spread, perhaps without even understanding what had been lost, until it was too late. The emotional reality of being the only humans is complex. On one hand, it gave our species freedom to expand without rivals. We filled continents, built civilizations, and reshaped the earth itself. On the other, it left us without companions who were close enough to understand us completely, but different enough to remind us we were not unique. The world became lonelier in ways our ancestors may have felt in quiet moments, sitting by a fire, remembering those who were gone. What would it have been like if they had survived? If Neanderthals had raised their children beside ours, if Denisovans had carved tools in the same valleys, if small-bodied hobbits had continued their lives on their islands, the world might have been one of shared civilizations, multiple forms of humanity building side by side. Instead, it is a world of one. In our solitude, we often imagine companions. Myths of hidden people, fair folk, or forest dwellers echo in cultures around the globe. Perhaps these stories are reflections of a deep memory, carried from a time when other humans were real, when the dark could hold not only predators, but other eyes that looked back, familiar yet not the same. Now, our only connection to them lies in fragments of DNA, in bones resting in caves, and in the questions they left behind. Their absence is felt in the silence where their laughter, songs, and footsteps might have been. We are alone on a planet that once held many kinds of us, and that loneliness is part of our story, even if it is rarely spoken aloud. The story of the lost humans is not only about the past, it is also a quiet mirror held up to us, showing what can happen even to the strongest and most resilient. Neanderthals endured for hundreds of thousands of years, longer than our own species has existed so far. Homo erectus survived almost 2 million years, outlasting empires of ice and fire. These were not fragile beings swept away in an instant. They were adaptable, intelligent, and deeply rooted in their landscapes. Yet today, they are gone, and only we remain. Their extinction is a reminder that survival is never guaranteed. Even the most enduring species can be undone by the pressures of environment, chance, or competition. For the humans who walked before us, climate shifts erased their hunting grounds, isolation narrowed their numbers, and encounters with our expanding kind may have pushed them toward disappearance. Each extinction carries its own causes, yet the pattern is the same. Resilience is not invincibility. When we think of our own place on this earth, this lesson becomes urgent. We live in an age where our species dominates the planet more completely than any human lineage before us. Cities sprawl across continents, machines carry us into the skies, and our voices are carried by satellites into space. Yet at the same time, we face challenges of our own making. Climate is shifting once again, not from ice ages this time, but from the warming brought by our use of fossil fuels. Ecosystems tremble as species vanish at a pace faster than at almost any time in the past. Even our numbers, vast as they are, cannot protect us from the weight of such changes. The fate of the other humans also teaches us something about connection. Those who survived longest were not always the strongest, but those who adapted best to change. Homo sapiens spread not only because of sharper tools, but because of wider networks of culture and cooperation. We traded, we told stories, we built bonds across long distances. It was these invisible threads that held us together when the world shifted around us. The lesson for our future is that our survival may depend once again on our ability to connect, to share knowledge, and to act as one species facing shared risks. Another lesson lies in humility. For much of history, we believed ourselves unique, set apart from all other beings. Yet the discoveries of the past century remind us that we were once only one among many. Our intelligence, our creativity, our art, even our sense of self, were mirrored in our cousins. They too buried their dead, shaped tools, painted symbols, and left traces of care and meaning. To imagine we are singular is to forget that the qualities we prize most were not ours alone. Their extinction and our survival may have been as much about chance as it was about skill. This understanding should temper our certainty. If Neanderthals could vanish after thriving for 300,000 years, if Denisovans could fade into the shadows despite their vast range, then there is nothing inevitable about our own endurance. The earth is older than us, and it will continue long after us. The question is not whether humanity is special, but whether we are wise enough to learn from those who came before. Perhaps the greatest lesson of all is that survival is not just about living through change, but about what is preserved along the way. The lost humans remind us of the value of diversity, of many ways of being and thinking. When their lineages ended, the human story became narrower. If we are to endure, it may not be enough to persist biologically. We must also carry forward the richness of culture, knowledge, and memory. The silence left by our cousins is not just absence, it is a warning. Extinction comes quietly as well as violently, through slow dwindling as much as sudden collapse. Their fires went out, one by one, until no one remained to light them again. Our challenge is to keep our own fire alive, not only for ourselves, but for the world we share with every living thing. The story of our family is still being written. For a long time, it seemed as though the map of human history was fixed. We knew of Neanderthals, Homo erectus, and ourselves. A few names filled the pages, and many believed the list was nearly complete. Yet the earth still holds secrets, and in the past few decades those secrets have begun to surface. In the deep chambers of South African caves, narrow passages barely wide enough for a body to squeeze through, scientists discovered the bones of Homo naledi. These small-brained humans lay in a chamber so hidden that even seasoned cavers struggled to reach it. Their presence there raised questions that ripple through archaeology. Were they placed in that cave intentionally, suggesting ritual, or were they trapped by accident? The discovery was startling not only for the mystery of their behavior, but for the timing. They lived far more recently than anyone expected, overlapping with our own kind. Not long after, in the limestone caverns of the Philippines, another surprise emerged. Tiny bones and teeth, delicate yet distinct, belonged to a species unlike any we had seen before. Named Homo luzonensis, they carried a blend of ancient and modern traits: curved finger bones, unusual teeth, and a mix of features that seemed to belong to both older and newer lineages. These remains were only a few centimeters across, yet they rewrote the human story. Suddenly, the idea that the tree of humanity had already been mapped seemed fragile. Each new find is a reminder of how much we do not know. The fossil record is patchy, like a scattered puzzle with most of its pieces missing. Bones rot, soils erode, caves collapse, and entire landscapes can bury or erase the traces of life. For every skeleton that has been uncovered, countless others may have turned to dust long ago. Yet even with these gaps, chance still delivers glimpses. A tooth no bigger than a fingernail, sifted from the soil, a fragment of jaw pulled from river sediment. From such fragments, entire species emerge. The discoveries of naledi and luzonensis came only in the past decade. That alone suggests that the Earth may still be hiding more of our relatives. There are regions of the world, thick with forests, mountains, and caves, that remain almost unexplored. In Southeast Asia especially, where islands and isolation often led species down unique evolutionary paths, there may be more human lineages waiting in the ground. The same is true in Africa, where our kind was born, and where layers of history still lie undisturbed beneath the soil. Genetics, too, hints at hidden branches. In our DNA, scientists sometimes find traces that cannot be explained by Neanderthals or Denisovans alone. Strange signatures appear, faint but persistent, suggesting we may have mingled with lineages that have not yet been identified. These ghosts leave no bones, only whispers in the code of life. If those populations were small, their remains may be nearly impossible to find, yet their genetic shadow tells us they existed, even if we cannot yet give them names. The possibility of more discoveries is not only exciting, it is humbling. It means the human story is not finished. Every excavation, every cave explored, every new layer of sediment sifted may add another face to our family. The people who lived before us were not a narrow line leading straight to us, but a branching forest of possibilities. Some branches were long and strong, others fragile and short, but together they formed a living network across the globe. The unanswered question is how many branches are still hidden from view, how many kinds of humans once walked the earth, leaving only faint traces for us to uncover, and what might their discovery reveal about who we are and what it means to be human. Even though so many of our relatives are gone, their presence has not vanished completely. Their bones may lie scattered in caves, and their faces may no longer walk beside us, but their traces still live on, hidden within our bodies. The story of human survival is not just written in the soil, it is also written in our DNA. And when scientists began to map our genetic code in detail, they made a discovery that changed everything. For years, many believed that when Homo sapiens spread across the world, we replaced the others entirely. The old picture was one of conquest and disappearance, but when ancient DNA was first extracted from the bones of a Neanderthal and later from Denisovans, the results revealed a different truth. Inside us were fragments of them, tiny stretches of genetic code passed down through generations, still alive within our cells. For those of us with roots in Europe and Asia, up to 2% of our DNA comes from Neanderthals. In some people from Melanesia and parts of Southeast Asia, as much as 6% can be traced back to Denisovans. These numbers may sound small, but their effects ripple across our bodies. They are not silent ghosts. They are active, shaping parts of who we are today. One example lies in the air we breathe. In Tibet, where the mountains rise so high that oxygen thins to a whisper, people survive thanks to a genetic gift. A Denisovan gene helps them adapt to extreme altitude, allowing their blood to use oxygen more efficiently. Without this inheritance, life at such heights would be far more dangerous. Neanderthal DNA also lingers in surprising ways. It influences our immune systems, giving us defenses against certain diseases that our ancestors once faced. Some of these genes help us fight infections. Others adjust how our skin reacts to sunlight or how our bodies store fat to endure colder climates. What began as a survival tool for them became part of us, carried silently into the present. Yet the story is not only one of benefits. Some Neanderthal genes are linked to traits that are less kind. Higher risks of allergies, autoimmune disorders, even the way our bodies respond to modern illnesses can be tied back to these ancient inheritances. Their gifts and their burdens remain entwined with our fate, even tens of thousands of years after their disappearance. When you look at it closely, it means that they never truly vanished. Every time a child is born, carrying even a sliver of Neanderthal or Denisovan code, those lost humans find a way to keep walking with us. They are not merely memories. They are embedded in our blood, in our lungs, in our skin, and in the rhythm of our hearts. We are not entirely Homo sapiens alone. We are a mosaic, a patchwork stitched from many human kinds. The ghosts of our blood remind us that survival was not a clean break. It was not one lineage replacing another. It was a mingling, a weaving together of families who met in forests, on icy plains, along rivers and coastlines. Sometimes those meetings ended in conflict, but sometimes they ended in love, in shared lives, in children who carried both legacies forward. Those children's descendants are us. It is a humbling thought that the story of Neanderthals and Denisovans is not just a tale of extinction. It is also a story of persistence, hidden inside every breath we take. Our species is not only ours, it is the sum of those who came before, and the echoes of those who walked beside us, their lives carried silently in our veins. It is tempting to pause for a moment and wonder how the story might have unfolded if those other humans had never disappeared. The Neanderthals, the Denisovans, the hobbits of Flores, and the hidden people of Luzon, all continuing their lives alongside us. History might have been a very different shape, woven not from the thread of a single species, but from many running together. Picture the Earth of today with more than one kind of human. Perhaps Neanderthals, with their strong builds and colder weather resilience, would still walk across Europe, tending fires in mountain valleys, carrying traditions passed down for hundreds of thousands of years. They may have built their own societies, guided by ways of thinking just different enough from ours to create new kinds of art, new forms of language, new philosophies we cannot quite imagine. Their songs would not be our songs, and yet they would be close enough to stir something familiar inside us. Across Asia, Denisovans might have risen into their own civilizations. Adapted to high mountains and thin air, they may have been the masters of high-altitude life, carving cities into cliffsides, thriving in places where oxygen fades and clouds drift low over jagged peaks. They carried traits we still rely on today in Tibet, and had they survived, Entire cultures may have blossomed in landscapes that remained out of reach for most of us. On the islands of Indonesia, perhaps Homo floresiensis, the hobbits, would still be hunting small animals in the forests, weaving myths in their tiny communities. They were so small, barely taller than a child, but they made tools and lived in balance with their world. What stories would they tell around their fires? Would their legends have spoken of giants the way we imagine them as tiny? Perhaps we would have seen ourselves through their eyes as towering figures that seemed almost unreal. The questions grow larger when we ask what it would mean for all of us together. Would the world have become a patchwork of different human nations, each species with its own territories and traditions? Would Homo sapiens have shared knowledge freely, trading ideas and technology with our cousins? Or would fear and competition have kept us apart, borders guarded, conflicts flaring whenever our paths crossed? Some scientists imagine that if Neanderthals or Denisovans had lasted longer, we might have lived side by side, forming alliances and friendships as well as rivalries. Our world could have been shaped by councils not of one human species, but of many, each voice adding something unique to the great conversation of civilization. Art, music, language, and technology might have been richer for it. There could have been whole philosophies, entire ways of being human that vanished before they were ever given a chance to grow. It is also possible that the presence of many human kinds would have changed how we see ourselves. The word human might not have meant one thing. It might not have carried the quiet assumption of being alone at the top of a tree. Instead, it could have been a broader circle, holding many different shapes, faces, and minds within it. We might have learned, from the very beginning, that being human is not about one form, but about many ways of belonging to the same world. This imagining lingers with a bittersweet feeling. We know that reality turned another way. One by one, the others disappeared, leaving only us to carry the story forward. Yet in our blood and in our bones, traces of them still remain, as if to remind us of what was once possible. They live on not as neighbors or nations, but as fragments of code, faint memories embedded in our very bodies. The idea of a shared world is not only a dream of what might have been, it is also a reflection of how fragile survival is and how easily history could have split in another direction. When we picture Neanderthals holding on to their last fires, or Denisovans looking out across mountain ridges, we can almost feel the shape of that lost future, a world where humanity was not one, but many. The human story was never meant to be told by one voice alone. For most of our history, we were part of a chorus. Neanderthals kept their fires burning in caves across Europe. Denisovans wandered the heights of Asia. Tiny hobbits lived quietly on their island in Indonesia, and countless other cousins carried their own ways of living, loving, and enduring. Together, they made the world more than it is today. But their songs have fallen silent, leaving only faint echoes in our blood and bones. We often imagine the past as a ladder, climbing step by step until it arrives at us, as though every twist of history was aimed at producing the humans we see now. But it was never a straight climb. It was a forest of paths, branching and intertwining, some flourishing, some fading. We are not the inevitable end of that forest, only the last branch still growing. Every other branch has been broken, not by fate or destiny, but by the fragile balance of survival. What was lost with them cannot be measured only in skulls and bones. Each species carried its own way of seeing the world. Neanderthals may have had a tenderness in their care for the wounded that rivaled ours. Denisovans carried resilience in their very blood, able to breathe in thin mountain air where we could not. The hobbits of Flores, small in size, proved that cleverness is not bound by stature. Homo naledi may have touched something close to ritual, carrying their dead into the dark chambers of the earth. Each of these lives was a thread of possibility, a different vision of what it meant to be human. And when they vanished, those possibilities vanished with them. Yet, even in their absence, they are not completely gone. Their fragments live within us, folded into our DNA. Pieces of Neanderthal still shape how our immune systems fight disease. Traces of Denisovans help some of us breathe more easily in high places. Their legacy flows through us quietly, unnoticed in daily life, but always present, in a way. We are not alone even now. We carry them with us, as whispers in the architecture of our bodies. It is a haunting thought that we are the last ones left. But perhaps it is also a responsibility. The human story did not belong only to us, but now we are its keepers. We hold the memories of all the lost branches, written in fossils, in artifacts, in genes, and in stories told across firelight. What remains is not only survival, but the choice of what kind of humans we will be, now that the world belongs only to us. So let me leave you with a question. If you could bring back one of our lost relatives, which would it be? Would you choose Neanderthals to see how close a sibling species might have stood beside us? Would you call back the Denisovans to fill the silence of Asia with a story still unfinished? Would you want to meet the hobbits of Flores, tiny yet clever, or the mysterious naledi who vanished into caves? Which voice in that lost chorus do you wish could still be heard today? If you have been drifting along this quiet journey and would like to continue exploring the mysteries of life, it would mean a great deal if you gently subscribed or pressed the like button. This is not an ending, but a pause before the next story. Together, we can keep wandering through time, unearthing forgotten chapters, and letting science itself remind us how wondrous and fragile existence truly is. So breathe in slowly and let the thought settle. The human story was never ours alone. Much of it is gone, but part of it still lives in you,